This is PreCalc 11, Chapter 2.5. This time I'm going to be looking at solving radical equations. So, solve as you do with regular algebra operations. What you want to do is isolate the radical and then square both sides. And what you might not be used to doing is checking your answers, and that's the main difference. You need to check for extraneous roots. Okay, so this means roots that are not in the domain or answers that do not fit the original equation. Okay, let's start with an example. Here we know the domain is x is greater than or equal to 0. Multiplying by 2 doesn't make any difference. If we had 2x is greater than 0, we divide both sides by 2, and then we would get x, and 0 divided by 2 is still 0. Okay, isolate the radical. So we need to divide both sides by 3. We have 4/3. Square both sides. So if we square this side, we get 2x. Now we get 16 over 9. It's 4 squared and 3 squared. X is equal to 16 over 9 times 2. We divide the 2 into the 16 and we get 8 over 9. This is in the domain, but let's check this in the original equation. 3 root 2 times 8 over 9 equals 4. 3 times square root 16 over 9 equals 4. This is 4 squared over 3 squared, so we have 3 times 4 over 3 equals 4. The 3's cancel out, and we have 4 equals 4. So our answer of 8 over 9 is correct. Let's try a slightly harder example. We need to isolate the radical, and we always adjust the adding or subtracting terms first. So we have 6 root 2x minus 1 equals, the 3 becomes a negative 3, so 7 minus 3 is 4. Now we need to divide both sides by 6. Now we square both sides. This is simplified to 2 over 3. So 2x minus 1. 2 squared is 4. 3 squared is 9. Now we just isolate the x. We need to move the negative 1 over to the other side, so we have 2x. This is positive 1. So 4 over 9 plus 9 over 9. X equals 13 over 9. And we need to divide both sides by 2. And our final answer is 13 over 18. Our domain. The domain is 2x minus 1 is greater than or equal to 0. So 2x is greater than or equal to 1. X is greater than or equal to 1/2. So this is in the domain. Let's verify the answer. 6 times square root 2 times 13 over 18 minus 1 plus 3 equals 7. What we would like to do is just work with one side, just leave the 7 alone. 6 times square root. We have a 2 in the numerator and 18 in the denominator, so the common factor is 2. So we have 13 over 9. 18 divided by 2 is 9, minus 1, plus 3 equals 7. Now, 1 is 9 over 9 using common denominators. So this is 13 minus 9. So we have 4 over 9. And that's 2 squared, that's 3 squared, so we have 6 times 2 over 3 plus 3 equals 7. Common factor of 3 in here and here, so we have 2. 2 times 2 is 4. That's close enough. We can put a check mark, and we're done. Another example. The domain here is a little bit trickier. It's 2 minus 3x greater than or equal to 0. When we divide by a negative number, we need to flip the sign. So we need to divide both sides by negative 3. And we get x is less than or equal to 2/3. Okay, let's isolate the radical. Divide both sides by 2. Square both sides. 5 squared is 25. 2 squared is 4. Isolate the x. 2 becomes negative 2 on this side. So this is 25 over 4. And the common denominator is 4, so that's negative 8 over 4. 25 minus 8 is 17. Divide both sides by negative 3. And we have minus 17 over 12. And minus 17 over 12 is less than 2/3, so it's in the domain. Let's verify this. 2 times 2 minus 3 times negative 17 over 12 equals 5. 2 root. We can cancel a factor of 3 out, so this is minus 17 over 4. Common denominator for here is 4, so we have 8 over 4. We got 2 negative signs, so that's plus 17 over 4. Eight plus 17 is 25 over 4. This is 5 squared and 2 squared, so we have 2 times 5 over 2. Cancel out a 2, and we have 5 equals 5. So this answer is good. Let's do another example. Our domain is negative 2x is greater than or equal to 0. Divide both sides by negative 2, so we flip the sign. So x is less than 0. Square both sides. Negative 2x equals negative 3 squared is 9. So x equals, we divide both sides by negative 2, minus 9 over 2. This is in our domain. However, let's plug this in. Minus 2, negative 9 over 2 equals negative 3. Cancel out the negative signs. We have square root 9 equals negative 3. 3 equals negative 3. So this answer is extraneous. Okay, so you can put an x here, or you can put 3 does not equal negative 3. And we got a couple more examples to go. If there's radicals on both sides, we just square both sides. But let's do the domain first. 3x minus 5 is greater than or equal to 0. 3x is greater than or equal to 5, so x is greater than or equal to 5 over 3. 2x plus 4 is greater than or equal to 0. 2x is greater than or equal to negative 4. Divide both sides by 2. And we have x is greater than or equal to negative 2. We need to use the most restrictive domain. This means where the domains overlap. So that would be this one. On a number line, we have 5 over 3. We have 0. We have -2. And we have 5 over 3. And we have -2. So 0 is not part of this domain. But if we look at 2, if we look at 3, that's part of both these domains. So that's why we take the most restrictive one. It can't be just part of one domain. It has to be part of both domains. Okay, let's answer the question. Square both sides. 3x minus 5 equals 2x plus 4. We'll bring the 2x over this side, so 3x minus 2x is just x. This -5 becomes +5 equals 9. And this is in the domain. But let's check for extraneous roots. We have square root 3 times 9 minus 5 equals square root 2 times 9 plus 4. This is square root 27 minus 5 equals square root 18 plus 4. So this is square root 22. This is square root 22. So our answer is good. Next example. Let's do our domain first. 2x plus 26 greater than or equals 0. Isolate the x. This becomes -26. Divide both sides by 2. And for this one, we have x minus 10 is greater than or equals 0, so x is greater than or equal to 10. This is our most restrictive domain. Because if we look at 0, 0 is part of this domain. 0 is not part of this domain. If we pick 11, it's part of this domain, and it's part of this domain. So this is the most restrictive. Let's calculate our solution. Square both sides. Bring the x over to this side. So 2x minus x is x. Bring the 26 over to this side, becomes negative. So we have minus 36. If we look at this, it's not in this domain. So, answer is extraneous. And that completes this lesson.